Let's recap the history of order of operations in about 60 seconds or less. First off, when algebra started to become more prevalent, late 1500s, 1600s, you'll see different dates at different sources, but that's when you start to see the beginning of order of operations. It was not as cut and dried as it is today, where you open up a textbook and it says parentheses first, exponents next, multiplication, division, left to right, in that order, whichever comes first, followed by addition and subtraction, left to right. It was not that cut and dried. It was more a loose knit group, basically an understanding of how you would handle these problems. Then late 1800s, early 1900s, the textbooks get involved, and you start seeing more and more rules put into it. And in fact, it has changed. If you look over here on this right side, 1980s, they would say do all of your multiplication before you do any division, and then do all of your addition before you do any subtraction in some books. Over here is today's current state of order of operations, and so it's changed, and it'll probably change before we die. It's just the nature of humans interacting with math. So there we go. That's basically what's happened. Let's take a look at today's incarnation of it. We're going to solve this expression right here using the order of operations. So first off, parentheses. That means we have to go and do anything inside parentheses first, and we're left with this right here. So negative 2 minus 2 would basically be the same as negative 4. And now if we pull everything down, we can then go on with our order of operations. We've done our parentheses. Check. No more parentheses. What about exponents? Well, you see our exponents are right here. What's 2 to the second power? That's the same as 2 times 2. So that's 4. And now we can go back through and pull everything else down that we haven't done. Each time you do a step, it gets it a little bit smaller. Just make sure you don't make a mistake. That's probably the number one reason that people miss this, is that they make a mistake copying it down or trying to do it all in their head. We've done all of our exponents. Now let's multiply or divide left to right. Since we see 12 times 4 is appearing first, it's on the left side of the expression, we're going to do that first. Then what we're doing is we're checking for any other multiplication or division, and you'll notice that negative 4 divided by 4 is negative 1. So now we've done all of our multiplication or division. Let's go through and do our addition or subtraction, left to right, whichever comes first. Addition's first, so that makes it 47 minus 5, and that's our last bit. Subtraction, 47 minus 5 is 42. That's how you handle the order of operations. Don't be alarmed if you see negative numbers in there. It's natural now that you're up in the higher levels of math, at least middle school math, and you're going to see that no matter where you're doing math. Now, there is one new type of problem that I want to show you, and it's basically we've got this fraction bar right here. So it's kind of like we've got a problem up on top, and we have a problem on the bottom. So I want you to treat these two things like they were two totally different problems. And to get that point across, I'm going to highlight the top in yellow, okay? And I'm going to copy it right over here to the left side of the problem. Again, treat it as if it's its own problem. So, parentheses first, that would be 3 minus 5. We'll make it negative 5. I'm going to leave that in parentheses there. And if you want, you can leave that negative 5 in parentheses, or you can just take the parentheses away now that it's down to one number. And since that 3 is sitting right next to that parentheses, it means 3 is going to be multiplying whatever the answer is. So there we go, 3 times negative 5 plus 5. We need to do our multiplication before we do addition. So 3 times negative 5 is negative 15, and negative 15 plus 5 is negative 10. Now, we also need to treat the bottom as if it's its own separate problem. So I'm going to copy that to the right side, and we'll solve the bottom. No parentheses, but we do have exponents. In fact, we got two different sets of exponents. 6 squared is 36. 5 squared is 25. There's our subtraction sign. That's the last thing that we do. So 36 minus 25 is 11. Now, let's stop and think about this. We simplified the top part of this problem down to negative 10. So negative 10 goes on top. The bottom part, simplified to 11, there's our final answer, negative 10 over 11. So remember, just simplify the top and bottom as if they were different problems. Put them together. After you put them together, if you can simplify that fraction, fantastic. If you can't, don't worry about it. That's your answer.